So, this is the book Introducing Astronomy. I've read the preface one video ago, and now I'm going to do the reading of this book here, the chapter 1 of this book, which is called Our Place in Space. So, I'm just gonna do the reading for this one, just practicing reading, and that's gonna be it. I won't speak in Portuguese in this book. At no time. If I'm going to search something, I'm going to search speaking in English 100% of the time. This is going to be a video where I don't care about Portuguese. I'm not going to be an explainer. I'm just going to read and try to understand that in my own way while I'm recording this, and maybe you've been watching this later. So let me get this started. Our place in space. We look out into the vastness of the universe from the surface of the planet Earth, a small rocky world that travels around the sun. The sun is a typical star, a self-luminous globe of gas, composed mainly of hydrogen, and helium, which generates its prodigious outpouring of energy by means of nuclear reactions that take place deep down in its interior. With a diameter more than 100 times greater than that of the Earth, the Sun could comfortably contain all over 1 million bodies the size of our modest planet. It is overwhelmingly the dominant body of the solar system. Oops, what just happened? Oh, I'd like to come back, man. Okay, I need to come back in a manual way. Okay, almost there again. Almost. Okay, here I cannot click in the bold ones here. Uh, overwhelmingly the dominant body of the solar system, a set of bodies that consists of the Sun, 8 planets, and their natural satellites, moons, a host of small bodies, and quantities of gas and dust, all of which revolve around the Sun under the influence of its powerful gravitational pull. Here's the Sun. Some spots, black spots, because of explosions that happen. It's like a crazy place to be close to. So the Sun, as imaged by the SOHO spacecraft on October 28th, 2003. The dark patches, not spots, really, patches on its visible surface, or the photosphere, are sunspots. Okay, dark patches are sunspots. So the use of spots here and the patches there. Our nearest neighbor in space is the moon. Earth's natural satellite. A barren, airless, rocky world with about 1/4 of the Earth's diameter. It revolves around our planet in a period of 27.3 days at a mean distance of 384,400 kilometers, maybe both, which is equivalent to about 10 times the Earth's circumference. Okay, this is the moment I've been waiting for all my life in this video here. The moment where I search something. Circumference. I'm not so sure about the sound of it.
Circumference.
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 Circumference. Okay. Whereas this distance that is relatively easy to visualize, whereas this is a distance that is relatively easy to visualize, it is often helpful to think about cosmic distances in terms of light travel time, the time it would take a ray of light, the fastest moving entity in the universe, to travel to a particular distance, moving at a speed of 300,000 kilometers. Okay, this is British. This is written in the British way because here is a kilometer.
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 Kilometer. Kilometer.
Okay, I'm gonna do a change now. I'll try to read in my British accent way. Alright. So, moving at a speed of 300,000 kilometers per second, a ray of light takes 1.3 seconds to reach us from the moon. By the time of comparison, the sun is about 300 times further away than the moon, and a ray of light takes 8.3 minutes to cross the 149,600,000 kilometer gulf that separates us from this our neighborhood star. Our neighborhood star. In order of distance from the sun, the planets are Mercury, Venus, the Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The innermost planet, Mercury. Mercury. Oh, God.
Mercury. Mercury.
Mercury.
Mercury.
Mercury. Mercury. Okay, yeah, I was here. Orbits at about 2/5 of the Earth's distance and takes just 88 days to travel around the sun, whereas the most distant planet, Neptune, is about 30 times further from the sun than we are and takes nearly 165 years to crawl round its much larger orbit. The light travel time from the sun to Neptune is just over 4 hours. Earth's nearest neighbor, the moon, showing its dark plains. Plane.
Plane.
Dark plains and lighter no. How do I say that? How do I say this word here?
Cratered.
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 cratered. Alright. Cratered. Cratered.
Cratered.
Cratered. Highlands. Highlands. Like that? Would I? Highlands. Please.
Highlands.
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 Highlands. The nearest. Oh God, man. So hard to speak in this British way. Near.
Near.
Nearest. I don't have any reference here. The nearest star, apart from the sun itself, is a dim red one called Proxima Centauri, a faint companion to the bright naked eye star Alpha Centauri. Centaur. Are you here? Centaur. How?
Center.
Centaur.
Centauri, Alpha Centauri, which is far less powerful than our sun and much too faint to be seen with the unaided eye, lying at a distance of more than 40 trillion kilometers. Gosh, why is it so hard to remember?
Kilometer.
Kilometers. Trillion kilometers. Lots of numbers. Lots of distance. It is more than a quarter of a million times further away from us than is the sun, and its light takes 4.2 years to traverse that great distance. Distance. So let me continue. Fully. The distance traveled by light in 1 year, about 9.46 trillion kilometers.
Kilometer. Kilometer.
Kilometers is known as a light year. Oh, now I was just sent here. Oh, it's not like so nice, you know. It's not like something a gentleman would do. I was light year is known as a light year. Expressed in those terms, Proxima Centauri lies at a distance of 4.2 light years. Part of the Milky Way. Of the two light stars to the left of center, the one further to the left is Alpha Centauri. Further to the left, Alpha Centauri, the nearest naked eye star. Okay. There are many points here. I see like some strong ones, but that's it. Powers of 10. A convenient way of expressing very large or very small numbers is to use index notation or powers of 10, where 10 in the 9 potency, 10 to the power n. Here is the answer. Denotes the number 1 followed by n zeros, and 10 to the power minus n represents 1 divided by, okay, for example, powers of 10 here. That's it. The scale model might help to give a feel for these distances. If we were to represent the sun by a large grapefruit 14 centimeters in diameter, the earth would be a small pinhead 1.25 millimeters in diameter, located at a distance of 15 meters from the model sun. Jupiter, the largest of the planets, would be a 1.4 centimeters small grape at a distance of 20, excuse me please, 78 meters, and Neptune, a 5 millimeters berry at a distance of about 450 meters. On this scale well, the same. The nearest star, Proxima Centauri, will be represented by a small orange at a distance of about 4,000 kilometers. If the model sun were located in London, the nearest star would be in Baghdad, Iraq. If it were in New York, the nearest star would be in Los Angeles. The stars are all self-luminous gas. This is killing me. This is killing me. All these words are so different for me.
Gaseous.
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 Gaseous. Self-luminous gaseous bodies.
Body.
Bodies. Gaseous bodies, similar in general nature to the sun. They appear so much fainter only because they are so very much further away. Although broadly similar in nature to our sun, stars exhibit a very large range of properties. At one end of the scale are stars which are hundreds of times larger and tens of thousands or even millions of times more luminous.
Luminous.
luminous,
luminous, luminous,
luminous,
luminous,
luminous,
luminous, luminous. Then the sun, while at the other end of the range are dwarf stars with less than 100,000th of the sun's light output, some of which white dwarfs are comparable in size with planet Earth. Some are more massive than the sun, some less massive, more massive, more massive or more massive,
massive,
massive, massive, massive,
massive,
massive,
massive,
massive,
massive than the sun, some less massive. Some are hotter, some are cooler, some are younger, and some older. In recent years, observations have revealed that many stars have planets, planet,
planet,
planets, exoplanets, exoplanets, and revolving around them. Our solar system is certainly not unique. All of the stars that we can see with the unaided eye on a clear, dark night are members of our galaxy. Oh man, once again, I'm here. Gotta come back. Galaxy, members of our galaxy, a huge star system which contains in total at least 200 billion stars spread out in a flattened disk-shaped aggregation that measures more than 100 light years in diameter. The solar system lies in galactic suburbs, some 27,000 light years away from the galactic center, the center of the galaxy. Our galaxy, commonly known commonly known as Milky Way galaxy, is one of well over 100 billion galaxies of vapor sizes, various shapes, sizes, and properties that lie within range of present-day telescopes. The nearest large one, the Andromeda Galaxy, so called because viewed from the Earth, it lies within the constellation of Andromeda, is 2.5 million light years away, otherwise known as M31, object number 31 in the catalog. Catalog of fuzzy nebulous objects published in 1781 by French astronomer Charles Messier. This galaxy is sufficiently bright, despite its great distance, to be glimpsed with the naked eye as a faint, misty patch of light. For most people, it is by far the most remote object that can be seen without optical aid. hard reading. Okay, this is Milky Way. No, this is Andromeda Galaxy, which is similar to but larger than our own galaxy, lies at a distance of 2,500,000 light years. What? It's that far? Is it that far? Jesus. The image shows the Hubble Ultra Deep Field 2012, which contains some of the most distant galaxies ever seen, some of which are remote than their light has taken 13 billion years to reach us. 13 billion years. The most distant galaxies are so far away that their light has taken more than 13 billion years to reach us. A period of time that is comparable to the age of the universe, and about 3 times as great as the age of planet Earth. When we detect the faint light arriving today from the most remote of objects, we are seeing them as they were billions of years ago when that light set out on its journey through space. Because light travels at a finite speed, our view of constant objects is always out of date. We see the moon as it was 1.23 seconds ago, and the sun as it was 8.3 minutes ago. If the sun were to be annihilated, let me see here just to be sure.
Annihilate.
Annihilate.
Annihilated at a distant instant at which you are reading these words. You would not become aware of the fact until 8.3 minutes from now. We see Neptune as it was some 4 hours ago, Proxima Centauri as it was 4.2 years ago, the Andromeda Galaxy as it was 2.5 million years ago, and the most remote galaxies as they were 13 billion years ago. Although the finite speed of light implies that we cannot see every object in the universe as it is now, the compensating benefit is that by probing further and further into the remote recesses of the cosmos, the cosmos, we can see what the universe was like in the distant past and examine how it has changed and evolved over the past 13-14 billion years. The scale of the observable universe, that part of the universe which in principle we can see from planet Earth in space and time, is truly immense. Truly immense. Yeah?
Immense.
Beleza? Então esse foi esse vídeo. Eu apenas eu li todo o capítulo, então, o primeiro capítulo deste livro. Apenas leitura. É um livro difícil, de certa forma precisaria ler de novo para realmente entender, né, prestar atenção em algumas coisas, né, também porque eu fiz uma leitura misturada, né, eu acho que comecei com o americano, a ideia do sotaque americano e depois a ideia do sotaque britânico, né, então tentando explorar esses sotaques também para ver até onde eu posso, né, conseguir chegar mesmo, e esse é um método que eu vejo como prático, né, que eu faço uma leitura, tento fazer uma compreensão, alguns fatos aqui, algumas ideias eu consegui captar, né? Em si eu entendi todo o texto, né? Porque o meu vocabulário está bacana, né? Mas de interpretação e tal, tem algumas coisas que eu provavelmente deixei passar por causa do meu treino de leitura. Mas enfim, esse foi um vídeo só de leitura do livro Introducing Astronomy, onde eu fiz sotaque em British e American, né, com as ideias e referências que eu tenho até o momento. Né, então, enfim, obrigado. Se você assistiu até aqui, se inscreva no canal, né, faça os comentários, qualquer coisa, qualquer necessidade. Tem os comentários aqui do YouTube, mensagens que você pode estar enviando e eu tenho maior felicidade de responder vocês. See you guys. Until the next one. Bye bye. Have a good day. See you in the next one. Once again, I say that. I keep repeating myself. See you in the next one.